We're going to graph functions in this video to find limits. These are the functions that I already graphed for you to save time on the video. And we're going to take specific limits on this and move pretty quickly through this. These are normal parent functions that you should know. The next video is going to be on piecewise functions, which is a little more difficult, but this should go pretty fast. So the first example we're going to do is a linear function, and we want to see what happens as we take the limit as x approaches -1 of this linear function, 2x minus 1. So here it is, and what we're doing is we're looking at x at -1 here. And we're approaching x as x approaches -1 from both the left and the right. So from the left as we go to -1, and from the right as we go to -1. And so, as we come down here to -1, this is our n, which happens to be -3. So in both cases, it's as x approaches from the left and the right approaches -1, our y value is -3, so that's our limit. The next one is the limit as x approaches 2, so we're looking at 2 here. We're looking as x approaches 2 from the left. So here's our 2. So what's happening as we approach 2 from here, and also approaching it from the right, from up to here. And we get that. We notice here that's our n, which happens to be -3. So our limit is -3. The next one is a cubic function that's been shifted down by 1 unit. We're going to approach -1, or what are we approaching here? Yeah, -1, which is here. We're going from the left. And sorry for the graphs. It's kind of hard to graph on the iPad. But anyway, so we're approaching from -1 here. And then from above, we approach and we get right here is our n, our limit, which happens to be -2. The next one is absolute value function, and we're going to look as x approaches -3. So we're looking as x approaches -3 from the left and from the right. So we're going from the left here to -3, so right in here, and then from the right we're going up from here. And that limit happens to be 6. So our limit is 6. We have a square root function that's been amplified by a factor of 3, and we're looking at the limit of 4. And it's pretty clear that our limit is 6. Again, you're supposed to approach from this side, and then you're also approaching from above the point. So that's the point. Sine function, we are looking at the limit as x approaches pi/2, and I drew the graph. Here's pi/2. I'm going to go up to my y value and see that's 1. So we're looking as x approaches pi/2 from the left and from the right. From the left, we're going up to this point, and from the left, and from the right, we're going up to this, and the answer is 1. Let's try cosine function, and I already put the answer here. That's okay. We're looking at pi, and this definitely is not a very good graph, so I'll make it a little better. Let me go down a little further. All right. As we approach pi, we can draw our line to our y value, and we get -1. Again, we're approaching from the right side and from the left side, and we still get -1. Okay, our e to the x function, we want to approach as x approaches 0. So as x approaches 0, from here, this is your 0. When we go to the x value here, we go to 1. And when we go from the right side, we still get with 1. So our answer is 1. Our ln of x, or natural log, or log natural, we're looking as x approaches 1 from the, is approaching, this x is approaching 1 from the left and from the right. So these are pretty simple. That equals 1. We have the reciprocal function, and we're looking what happens as x approaches -1. So when you're looking at that, we're looking at here, when basically this is not drawn very well at all. So if I drew this better, we're approaching -1. This should kind of, let me erase this real quick. Sorry, folks. So basically, if I were to graph this, this would look like this. And this side, why did I do that? And this side would look more like this. But we're just looking at this portion of the graph because we're looking as x approaches -1 from the left on the curve, and then from the right on the curve. And our answer is -1. And this last one, I didn't graph this well at all, so I'm just going to erase all this. It's 1 over x squared, so I'm going to put my -1 here. Let me just erase all that. And 1 here. So this would be 2. These are just sketches. So it looks like this. It goes down like that. And goes to 1. Goes down to -1. This one's kind of harder to see. But the limit as that we're approaching 2 here is actually 1/4. Okay, and that's hard to see from a graph unless you actually plug in points here. And so what I'm going to do is I'm going to go ahead and substitute 2 in for x. So 1 over 2 squared equals 1/4, and that's basically our limit. We'll be doing more of this when on our video on algebraic techniques for finding limits. The next video I'm going to do is the piecewise functions that happen to be a little harder. This will be called part 2 of graphing to find limits.